Greetings once again, students. We continue with our C programming lesson. We are going to look at iterative statements, which we called repetitive or looping. The same concepts we mastered in VBA, we should be able to apply them here in C programming. What differs is the syntax. The first step in any iteration is initialization. This happens when the counter variable gets initialized to an initial value, then a condition. A condition will be checked always until the condition becomes false. Then the iterative statement will stop execution. After successful execution of a loop's body, the counter variable is incremented or decremented using the plus or minus, whatsoever applies to the problem being solved. We went through this flow chart in VBA, and the same explains the concept of looping, the concept of repetition or iteration as it is called by others. So let's remember these building blocks of all looping constructs in any language. The same example we used in VBA, we will mention it here again. The initialization step here is assigning I a value of 2. Then the condition being tested for is whether I is less than or equal to 6 or it's not. If it is, there is a statement that is being executed. And then after that statement, there is an increment of I by adding 2 to I. This process continues until the condition is violated. Once the condition is violated and becomes false, we exit the loop. This is the syntax of a for loop in C. For initialization, the condition being tested, the increment or the decrement. You can apply that example on a new program file, which is going to print the text hello world for 3 times. First, it will print it when I is equal to 1. Then I will be equal to I plus 1. It prints it again when I is equal to 2. Then I is equal to I plus 1, which is equal to 3. Then it prints it again. When it comes back by adding in 1 to I becomes 4 and the condition is violated, so we exit the loop. That is how we do the loop. There are different ways of iteration in C. I would like you to explore these as shown in your notes and examples. We can also nest loops just like we nest ifs. That is to have a loop within a loop, as in that example there, where we are basically printing the numbers in the first loop, which is I, and in J. We have embedded the loop for the variable J inside the loop for the variable I. Think of real-life problems which you need to solve by iterating or looping as you go through this course. A break statement is used to exit a loop. You can have a condition which is being tested, and when that condition passes, you can break out of a loop by using the break statement. It is a keyword and a reserved word in the C language. Let's move on to recursive functions. A recursive function is a function that calls itself during execution. It enables the function to repeat itself several times, outputting the result at the end of each iteration. Like an example would be to find the power of a number. To find the power of a number, you will have to call the function several times within the execution until you have broken down the problem into smaller manageable pieces which eventually compute the power of a number. Same as when you're calculating the combination of numbers. You would definitely use a recursive type of a function. You are encouraged to try this code example where you're calculating the power of a number given a number. So the parameters to be passed to the power function are the two numbers. If I want to say 2 to the power 3, it means I'll pass on to power 2, 3. And the system will compute the power of 2 to the power 1. Then it calls the same function to compute 2 to the power 2. Then it does it again, 2 to the power 3. So 2 to the power 3 will be a function of calling the power function of 2 to the power 1 3 times. That's recursively calling the power function within itself. An example there will be for you to calculate the factorial of a number. This is a typical example of a recursive function call. You can try this solution in your compiler and see the result that comes out. Let us move on to arrays. Arrays in C programming are one of the frequently used as they handle similar data types. For example, if you want to store marks of 100 students, it would be difficult for you to create 100 variables to keep each and every student's mark. Rather, group them all together into an array of student marks and then automatically assign the marks with minimum code. So arrays can help us to minimize the lines of code that we use, especially on the same data type where same operations are performed on that data set. This is how you declare an array in C. You need the data type like any other variable, then you need the name of the array and the size. Let's say you've got a class of 20 students. You could call the array to store their marks. It should have a data type of int and it could be called geography marks, and the array size will be 20 to mean that there are 20 marks of students being captured in that array. Every array needs to be initialized. You can initialize an array by setting the values before it's used. Like you could assign the student marks based on the marks being input by the end user of your application, or you could have some default marks being set as the initial marks to be manipulated later in the program execution. The elements of an array are accessed via the indices, where you use the name of the array and the square brackets. Inside the square brackets, you determine the index of the element, i.e. the first element of an array will be at index 0. In this case, where we've got an example of the age of five students, element 0, that is the first student, will be on age square bracket 0. The second one, age square bracket 1. The last one will be on age square bracket 4. That means because the array numbering starts at 0, then the last element will be n minus 1 of this, where n is the size of the array. You need to be mindful of the different programming language, where some languages will start at index 1 instead of index 0. You can try this example of the student marks using arrays. The program is meant to allow you to input the number of students you want to deal with, and for each of those students, receive the mark of the student, and at the end of it all, have a total sum of all the marks for the student. Another example you need to do at your own spare time is a C function that calculates the volatility of a stock with the following price movement. You have to here create an array that will keep track of the price movement. And you know the formula for volatility from your other courses that you have learned. You use your standard deviation and compute it, and you are able to tell the volatility based on the use of the arrays as the data structure. This is the solution that you should come up with. We have come to the end of our C programming. We have touched all the constructs, the if statements, the looping statements, the structure of a C program, how you start with the pre-processed directives. You should always have the main function. Each statement in C is terminated by a semicolon. Each program in C should have comments where you describe what the program does, and these are enclosed in a forward slash and a star and a star and a forward slash. Thank you so much for taking time to be part of this C programming lesson. We meet at the next lesson.